All right, yo, we're back for another episode of the Open Research Series. Um, I just saw a little lizard crawl through my Airbnb, which threw me off for a second. I hadn't seen that one before. I'm in Bali right now, and there was a monkey that like came into our place yesterday and actually stole a cookie out of our fridge, and now I'm seeing some lizards. So anyway, yeah, so we're doing another episode of this open research series, this time on novel execution environments and VMs, and we got our dear friend Wei Dai here from 1KX. So thank you for joining us, Wei.
Thanks for having me. Great to be on here.
Of course, of course. Okay, so let's set the stage. So first off, we're gonna try to make this pretty like efficient. We'll go, maybe like a little over a half hour, but we can try to make it dense. Let's set the stage with how you guys think about VMs and execution environments. So yeah, what is a VM? Maybe I'll wait. You could try that first.
Yeah, I'll take a stab at it first. I think the word VM, virtual machine, has been overused in the blockchain space to also include execution environments, right? So I think if you think about EVM, SVM, and other VMs, it's actually both the VM, the virtual machine, like how instructions get executed, and also the execution environments, meaning how transactions actually get processed. How do you modify states? How do you reverse transactions? And all of that, I would say, it's traditionally not part of the VM design, but within a blockchain context, is the VM is the entire package, and so that includes what set of transactions, what set of opcodes there are, what do they do, how are transactions executed, how do they modify states, how do they get reverted, how do contracts call each other, and all that, and even more recently, right? How do you execute transactions out of order? How does that work semantically, and so on and so forth. And I mean, it's a really fascinating segment of blockchain design, and I think there's has been a lot of progress since the early days, right? Since Bitcoin scripts, and there's probably more progress to come. Yeah, very exciting area of blockchain research and development. Dimitri,
Yeah,
anything to add?
Yes, I would say yes. Actually, my take on this is very similar to yours. I think there are two definitions of VMs. The general basic definition of VM, where we suppose that it's some general purpose instruction set, like some ICA that is used to execute uh, the pure function with some with definition of inputs and outputs, and it's quite straightforward for everyone how to use it and how to compile and blah blah. But what we see in blockchain industry, what they call VM, is usually context dependent execution environment based instruction set. So it is semi VM because it has some VM functionality inside, but it also depends on the execution environment where it's located. Like it provides some instructions for retrieving information about your balances, transactions. That also can be used to execute transactions and etc. So from the normal VM definition, it cannot be called VM, but we have it today that everyone calls VM. So what to do? That's why it's hard to put a strict definition of the VM, because if we define this, if we create such definition, then all existing VMs are not VMs anymore. So let's say VM is something that can be used to transit the state for your transaction or for some input, and your transaction is usually the input.
Yeah. So before we actually move on for this, how did that happen? Did the EVM like just was it the EVM that just kind of bastardized all this, where they called like the little sandbox the EVM, and then like the whole execution environment the EVM, and then people just clung on to that? Is that what happened?
Perhaps that's the case. I think at least I'm not blockchain historian, but it seems to me EVM was really one of the first, and it was aptly named, right, Ethereum virtual machine. But maybe you should have been Ethereum virtual machine plus Ethereum execution context, execution environment, triple E, I guess. But maybe the name just caught on, and because EVM has the unique feature of being atomically composable across contracts, and I think that's the reason why one of the reasons why it really caught on. and that's a feature that people still talk about in the rollup world, right? How do we add atomic composability back to rollups, right? That are independent. And EVM was really the only environment then that really allows contracts to call each other and while holding a part of the transaction pending, right? So you could do some state changes, do a contract call, and then come back and do more or revert prior state changes. And that's something that's really powerful with EVM. And yeah, and I think there's different designs now, and with SVM and Move and Fluent. Yeah, but there's a lot to talk about. But yeah, EVM is definitely where things started.
So we'll linger on EVM for one more moment. I know you're not a blockchain or VM historian, but like how how did the EVM get so popular, right? Like, I mean, what are the sticky aspects of it? It gets so much slack from a technical perspective, which we could talk about in a moment, but at the same time, it's like so widely used. So why is that?
Yeah, I think coming back to my previous answer, right? Like atomic composability is really the unique feature of EVM, at least at the time when things really start to take off. So effectively, another way to view it, like this is an explanation I've been explaining, is that it's actually one application. So entire EVM chain is really one application because of atomic composability. So each contract is actually one part. You can think of it as kind of one library that's one part of the application, rather than each contract for each step being independent applications. And EVM has a lot of downsides that we have known over the years. So for example, the large word size is actually not a great feature for execution performance. For example, a stack-based approach is really easy to implement, but it's actually hard, for example, to make it secret friendly. And I think Solidity to a certain extent also really helped EVM. That there's a smart contract language that was really the official language, right? And if you look at all the EIPs, everything is actually specified in Solidity, right? So EVM Solidity, this pair is actually it's not just EVM, right? It's also the language. I mean, there are others like Viper, but they don't. It doesn't have as much usage, and Solidity is really standardized. And yeah, and there's definitely the good and bad of EVM, but to recognize the good, right? Atomic composability and the fact that there's a language that is pragmatic. It's usable, and people don't like it at times, right? Like there's contract size limit on Ethereum L1, and there's there's the stack height limits, and there's a lot of different quirks about EVM, but it works, and it really allowed the Ethereum ecosystem to flourish. And now we're thinking about like how can we fix all the quirks, all the problems with EVM, right, while preserving things like atomic composability and then nice features. Yeah.
Let's pick it apart just a little bit more. Like, and Dimitri, feel free to jump in if you have different kind of qualms with the EVM. But just from a technical perspective, like, what are the main problems and what are the implications of those problems? Like, can you guys like explain it like I'm five?
Yeah, I also want to add to the previous question. So I think EVM dominates originally, yeah, because it was originally the first well adopted blockchain language and blockchain in execution environment. But I think the major thing that it had a lot of developer docs documentation, and it used very, very simple and quite self-explaining standards for structures. So so even starting with, for example, RLP encoding, it is very simple. Without even knowing the structure of the data, you can easily decode all this data using your eyes and understand what is located inside. And comparing to other, for example, prefix-based or standards without prefixes encodings that are very annoying, where you need to strictly follow all encoding standards, etc. So it makes for developers very easy to use Ethereum because it used quite simple technology for developers, and developers can easily understand them. And also, of course, EVM itself, it's very, very simple. So everyone can develop their own version of EVM like in days. and create their own interpreter. You just need to define the subcodes, but all the subcodes are quite simple. And yeah, could you please repeat your current question?
Yeah, I was just gonna ask if you can pick apart some of the technical qualms that you have with the EVM and what some of those, and if you can make it as simple as possible to understand what the negative implications are.
Honestly, it's really hard to measure because I love EVM and everything that happens inside. I like it because it has a really nice splitted structure. So it has the structure itself, and it has standards inside. And the structure is fully distinguished from the standards you have. And you can take, for example, all EVM structures, and you can fully replace its internals, the same actually as Fluent does. And you can replace all these internals, and you can still be like EVM compatible. You can use the same, you can inherit the same nature of EVM, but you can expand the functionality and more features. So from the architecture design, EVM is a really, really well designed solution for developers to expand the ecosystem, to add more functionality, etc.
Yeah, maybe I can answer the question in a different way. I think like we have mentioned, right? EVM has many different parts, right? There's the VM, there's the execution environment. And I think Dimitri might be actually referring to the state structure and like the for example, like how contracts call each other and the cross contract call stack. I think those are really, really well designed. But if you look at, for example, certain instructions that perform computation, there's no reason why, for example, catjack is an instruction but SHA is not, right? SHA is precompile on most EVM chains. So another example is the word size, right? So it was originally designed to be friendly to cryptographic operations. But I think now the general consensus is that we can emulate cryptographic operations with 32 bits worth of 64-bit words instead of having to use 256-bit counters, right? Which is very, very inefficient. That has ramifications. For example, if you want to ZK5 the entire VM, right, to make a ZK rollup, it makes it harder. If you want to, there's a lot more overhead. Another example is, for example, the fact that EVM assumes that things are executed sequentially, and this is something that that's inherent to EVM. So we could actually add optimistic concurrency to EVM, meaning we can start to execute transactions in parallel and try to resolve conflicts afterwards. And this is, for example, block SDM. Many EVM projects try to do this, Mega ETH, Monads, so on and so forth. And the problem is that we don't know whether transactions will conflict beforehand, because EVM transaction can touch different parts of the state dynamically when they're executed. And whereas on something like SVM and Sui move, we don't actually have that. We can actually determine ahead of time whether transactions will be conflicting or not. And so there's definitely aspects of EVM that are not ideal in modern standards. But there's a way to fix them. For example, to use block STM and to add concurrency, but the ceiling it's probably lower compared to something like SVM or Move, where you can actually have concurrency that can schedule ahead of time. But yeah, there's many more things to add, but I'll stop here.
Yeah, totally agree. Also, yes, I want to say that there are like tens of different problems, and I mentioned before, yes, that the nature of EVM to be like expandable. And for example, if you have issues with running non-optimistic parallelization, yes, of course, it is possible to invent a new type of transaction with, for example, strict access lists that define strictly the number of slots affected in the state, for example, or the potential nested calls that are required for the transaction to be executed. Also for EVM, the same. You can, by using EOF, you can, Ethereum object format, you can use different types of bytecodes inside, and it's possible. I think the biggest pain Ethereum has right now, the biggest, is all the legacy code it has inside. and all required heaps and standards and all outdated contracts that never will be removed from the chain. And the chain must support all these chains, all these contracts all the time, without ability, for example, somehow to drop them or migrate, because the migration process can be like extremely painful for this. But that's the thing we cannot change, because when Ethereum originally were invented, it was like more than 10 years ago. So at that time, we didn't have normal execution engines. We didn't have normal VMs like WebAssembly. It was like an experimental standard that were developed by Mozilla, but nothing practical were produced at that time. So there were, I remember, like everyone were using Java bytecode and sometimes outdated .NET framework. That's it.
So what's kind of nice about the SA like L2 centric design is it gives us like a clean slate for new types of VMs to pop up. You don't have to have all the same baggage. And so we're starting to see, well, after a couple of years of this like EVM copy paste proliferation, we're starting to see a bunch of interest around alt VMs. And there, you guys touched on a couple of them before: SVM, MoveVM. We have our like blended VM, Wasm VM. What and each of them come with different like attributes that many people find compelling, and you touched on some of those as well. But just to kind of bring it all together, which attributes of these different VMs do you guys find most compelling?
I guess
yeah, Wei, you could start.
I can start. I think SVM starts to think about performance, right? So EVM was really okay, functionality. What can we do with DeFi and NFTs and so on and so forth? And SVM limited the size of a transaction, right, and allowed concurrency to happen. And in Solana, the entire ecosystem is kind of anchored around performance, and SVM was designed to be that. And that use the Berkeley packet filter, right? It's technically that's the VM. The Move VM really focused on security, right? And so EVM, for example, there was a DAO hack, there was reentrancy problems, and Move really started to think, okay, can we actually enforce the semantics of non-copying, right? The fact that like you have a piece of object that cannot be copied, and the ownership can only be moved, right? And that's where the name comes from. And I think with Wasm is, Wasm entire family of VMs is thinking, okay, what is the language that we're going to use? Do we like Solidity, or can we use something more standard, right? Like Rust. And also back to SVM, I forgot to mention one thing. So there's a huge focus on concurrency, right? And then I think there's now a newer family of VMs that are, thinking about concurrency in a slightly different way as well. So whereas before is really about, okay, can we execute transactions in parallel? And now, because maybe had to spend a little bit of time to set the context. There's this new class of orderless consensus protocols. So for example, if you have seen Delta or Pod, they will actually sweet to a certain extent. The result of consensus is not actually a bag, a sequence of transactions, but instead a bag of transactions where we don't actually necessarily know the ordering between them. And it turns out, you can actually mix sequence transactions and non-sequence transactions. So, for example, on the EVM, right, everything is inherently sequential. At the very end, you have the notion of a block, and the block gets executed from the top to the bottom, right? And the top of the block is where MEV happens. But it turns out you can actually potentially mix this. So, for example, if two applications are sequenced themselves, then transactions touching those two applications can come from a consensus protocol in a non-sequence manner, and then they can still within them sequence the transaction that touch those two applications, right? And that's something that I think is very exciting. Like just looking forwardly, what is happening in this space, if you want to push performance even further. So yeah, wrapping up, like security, performance, expressibility, right, with which type of programming language, and those are probably the three main directions people have taken LVMs to do.
No, that makes a lot of sense. Dimitri, do you have any kind of different takes on that, or like which elements, which attributes of these different VMs do you find most interesting? Obviously, we chose WASM, so feel free to kind of like touch on some of our
Yeah.
design decisions too.
Yeah. So I find so each attribute in this VM I see as an extremely helpful feature for developers that can change the game and how they develop the contracts. So it is nice to have a place where we have all these languages in the one place. So if there is a place, then it's so helpful. So I can say I'm really maybe my brains are a bit corrupted of VMs, so I don't see the difference between VMs and its attributes at all, because like it's only the way how you interpret information. But for developers, it's important to use right VM in the right place. For WebAssembly, I love WebAssembly. I've been working with WebAssembly for like 10 years, starting from all these experimental standards. And WebAssembly is a nice language to represent most of applications, because maybe it's not extremely efficient comparing, for example, to some risk-based languages, but at least it can be used to represent in the simplest way, even complicated applications with its quite simple memory model, with a very simple stack-based model, etc. That you also don't have to use. You can do some optimizations. So from my perspective, you can, like, using blended VM, you can represent most of uh, requirements for developers using WebAssembly, because it is driven by, for example, LLVM. So you have support for around 20 languages by default. It is extremely important to make sure that it doesn't raise additional it doesn't raise additional vulnerabilities for developers, reentrancy attack or state races, etc. And Move already has special constraints, because if you develop a contract using Go, you must be aware of all these potential vulnerabilities and manage state carefully. That is already implemented, for example, on Solidity. So my take on this, I think the most helpful thing for developers to keep as much attributes as they need. For example, if they want to manage state very, very carefully and manage storage, make sure it's compatible with, for example, EVM storage design with, let's say, ERC20, they can develop it using Solidity. If they want to bring some heavy, intensive computations inside their controls, they don't have to do it as using Solidity, because it's not efficient. Instead, they can use, for example, Rust, Golang, or just a WebAssembly VM to create their own precompiles that bring additional cryptography and etc. So from this perspective, I think it really makes sense to find ways how to run as much alt VMs as it possible, or to try to represent other languages through their other alt VMs, for example.
Let's unpack that a little bit more. Like, clearly what you're getting at is our own kind of design of blended execution, and how we're using this WASM VM to basically, simulate other VMs, and therefore let developers get the attributes of a number of different alt VMs in the same place. Can you talk a little bit more about how we actually accomplish that? So, like, for people who are listening and are new to this, it's like, what do you mean you have one VM that can actually run different programs and support different tooling, like, from these different ecosystems? Like, how does that work? And I know even before we got online here, Wei, you were talking about how the actual interactions between like these kind of apps from disparate environments work. So Dimitri, can you just like talk a little bit more about that? And Wei, feel free to chime in with questions.
Yeah, so it's the way how blended execution works. So blended execution, I like to call this the execution concept, where you represent different VMs or different transitions using the same language. It doesn't matter how you represent. You can use it. You can use emulator software, so you can run, for example, EVM using Rust language and compile it to WebAssembly to execute, or you can create an ahead of time compiler to translate it directly from EVM, for example, to WebAssembly and execute it to flight, etc. But it's the concept that uses only one VM to represent all state transitions. And all state transition must be defined using only this intermediate representation language. So in Fluent, it has only one VM. The name is RWASM, that stands for Reduced WebAssembly. It is slightly modified version of WebAssembly that has reduced binary structure and reduced ISA to optimize the execution and especially proving for creating ZK circuits. And yes, so yeah, I can talk about blended VM and blended execution for hours, but if we have some specific questions,
I have a question actually. So I think in the context of like the actual instructions, I think RWASM it's a great choice, right? It's ZK friendly and you can emulate most of the or any arbitrary right piece of computation, and actually the VM in the VM context, right? That part makes sense to me. And what is kind of tricky, I think, to get is actually how to manage states, right? How do you so when a transaction come in, for those in the audience or for like just as a refresher, right? So EVM transactions only specify kind of a context or a contract you're calling and call data. And there's extra kind of authentication going on with signatures and so on and so forth. But really, what passing to VM is really what contract is executed first. What is it called data, right? And so that has selectors and all that. But in SVM, right, the format of transaction is different. You actually lock the accounts that you touch, right? So I guess my question is, let's blend SVM and EVM. So forget about move for a second. What is the format of a transaction in Fluent, right? Is it more like EVM or is it more like SVM?
Yeah. So as I mentioned before, I like EVM. I like EVM for its very simple and very flexible and expandable structure. So if we take a look on the call data, we can find that it says nothing about what's happened inside or what's happening inside. For example, when you deploy your EVM contract, you just create a special deployer bytecode and you specify the bytecode as a call data as the input of your transaction, and you specify a magic recipient, a magic nil, empty account, and the magic happens inside when you decide how to represent the information you pass. And you actually can define different ways how you can represent. And the trick is that you can, for example, you can even create system transactions and manage them like in any manner you want to deploy different contracts using different system precompilers. You can create a precompiler for managing EVM applications and for managing EVM state. And you can use internal state and store the EVM, for example, natively make it atomically and natively composable with all other, for example, virtual machines and with all other like languages. And you can create the same contracts for WebAssembly, for like Solana, RPBF, for any language you want. So how they manage the state? They manage the state in exactly the same approach. So they just manage the state. So we have only one state tree, and we call it execution environment simulation toolset, where we define how we represent operations in one particular VM into our state tree. For example, when you request a balance in your EVM application, we create a special wrapper that defines how for EVM we extract this information from our state tree. And we do the same, for example, for Solana. We do so-called account mapping. So we map Solana accounts into Fluent accounts. It helps to build sorry, it helps to build the following. You can keep SVM and EVM in the same state tree, and you can make all these contracts interoperable. So EVM contract can call Solana contract and vice versa. It's happened because of how you represent addresses in the memory. You can just calculate the same binary path for Solana addresses and for EVM addresses, and we're developing this concept right now. And it helps to store all accounts in the same place and make all of them interoperable. And the system itself, Fluent or Blend execution, it doesn't aware of VMs inside. It just knows, oh yeah, I have some contract. It is all the time developed using our WASM language. So it's not aware of anything else. It knows only one R WASM language. That's it. And what happens next is for the blended execution is magic, because it's just a set of contracts that represents or simulate execution environment for Solana or for EVM. It doesn't matter. So tons of magic can happen inside, but that's like the blended execution.
So would you say that this is inspired by the EVM state tree design? So we're basically working off of the EVM, states and cross contract calls, and we're replacing the actual EVM opcodes with RWASM, right? And then we'll use RWASM to emulate SVM and other VMs.
Yes, partially true, because not every operation in Solana you can represent using EVM state, of course. So we have slightly modified tree representation to be able to represent Solana structures as well.
I see. I do have a follow-up question. So like the question is actually, how do we do concurrency? And I think this is a big question mark, right? Like there's overall two approaches: optimistic concurrency and then kind of pessimistic concurrency. So the difference is, do you declare the accounts or state variables, storage slots that you're going to be touching beforehand, and are you bound to them, right? And in EVM, we can do state access dynamically, meaning before executing a transaction, we'll have no idea what which part of the state the transaction is touching. It could be any arbitrary value in like the gigabyte large state tree. Whereas in SVM, right, this is specified ahead of time. In constant time, we can look at the transaction and see which part of the tree is touching. So I'm curious what is happening in Fluent.
Yeah, so actually we're still researching this. We're researching between using optimistic and pessimistic approach. We're aiming to use pessimistic approach by introducing much stricter access lists and use them to represent both Solana and EVM account list, the same as Solana has, for example. And yes, Solana has a much more simpler design of the storage, because for you as a developer, there is no need to define a list of slots in the state, because it's not a tree. It's just a chunk of data. That's it. But for EVM instead, you need to specify each slot in the tree you can theoretically affect. We're still researching how to make it optimized, because after Cancun fork, there is no need to store nested trees anymore, and you can optimize the storage by elaborating all nested trees for managing storage. So it's a bit tricky thing. But yes, our current approach is to use pessimistic access lists.
Got it. Yeah, I think that has higher ceiling, right? But it does have effects on dev friendliness, I think. So you have larger transactions. That's one thing, right? Mechanically, transactions could be larger, and this is why in Solana they have the entire kind of feature addition where you can pre-specify a list, right? To have a pointer to a list. And I think another question is kind of, what is ramification to devs, right? Is this as friendly to program as the EVM, or have we changed something by using pessimistic concurrency?
Yeah, so in the current version for developers, it doesn't affect developer experience at all. So they just the only requirement might be is to use our custom deployer. So we have toolset that must be used to deploy the application, and that's the only difference. And for EVM users, there is also no developer experience at all. There might be some potential theoretical invocation issues for some specific contracts, that, for example, depends on the state position and it relies, for example, on the block number, and it calculates the state using block number. In this case, pessimistic access lists won't work because so theoretically, I can create a contract that all the time use a new slot, and theoretically, it's impossible to pre-calculate. Maybe it's possible to pre-calculate, but it's not the part of Web3 development experience to pre-calculate all potential future access lists. So we're thinking maybe to use some like semi pessimistic execution approach where we try to execute all pessimistic parallel transactions before and create a special queue for a type of transaction that cannot be parallelized using a special transaction type, for example, or legacy transaction type. It's still under research, so it requires a lot of effort to estimate the percentage of such transactions and how often they appear, for example, in Ethereum right now, and later we'll be able to decide on what design to use. Yeah.
I was going to ask, actually, on that note, what other trade-offs are there to this design? Like, just for people who are listening, who just want like a simple way to think about it from like a dev perspective and a user perspective, right? So like, I'll just set the stage with one, and you kind of touched on it. Like we don't want to fracture the state. So like we want to have like SVM, EVM, WASM, very simple, sitting there, one state machine. And all the contracts can talk to each other, but that doesn't, there's no free lunch. And I know one thing that we've talked about internally is we're sacrificing support for SVM wallets. Like we're like tailoring this thing around EVM more so than other VMs. Are there other types of trade-offs that people should be aware of? Or is that the main one? I know that's actually just like transparently. That's the one we've talked probably the most about internally.
The goal of blend execution that it doesn't accept any trade-offs, and we're trying to make developer experience. We can try to make the smoothest developer experience and let them to reuse their existing tooling without thinking about what can happen. The example I provided before, it's quite tricky example, and I don't know are developers aware of such type of applications that somehow can do a lot of false positive access list misses. So in terms of user/developer experience, there is no any additional trade-offs they must be aware of because the execution environment itself is fully compatible. In terms of performance, for example, so yeah, before we mentioned about pessimistic parallel execution, small transaction types. And the biggest important thing to know about Solana is it is a decentralized solution. So for Fluent, it's not an issue right now because Fluent is driven by ZK technology and can prove most operations. And for ZK-based technology, it's fine to have semi-decentralized solution, or let's call it semi-centralized solution, where we can optimize hardware and execution environment to execute transactions faster with, for example, bigger transaction size, because there is no need, for example, to fit into each network pocket. We can just establish a very stable connection between different data centers and make sure that the losses of transactions is minimized here on these particular channels. So in terms of performance, I don't think we'll have any significant performance losses compared, for example, for Solana users. And but as a trade-off, let's call it a trade-off, by running their applications in Fluent, they get much more additional benefits on having their applications on Fluent, because now that they are fully interoperable with EVM apps, and they can build a new type of applications. So
one thing
Oh wait,
yeah,
no,
like
go.
the I think the trade-off is there's definitely a trade-off between expressivity with dev friendliness, right? And this happens across all programming languages, right? You can program things in C, C++, and not dev friendly, but it's very performant and expressive, right? In terms of exactly what you want to do at the kind of machine level. And the same thing happens in I think blockchain development. so there are, I think, novel features that are emerging. I'll maybe mention some of those. So for example, I think the difference between launching a contract and launching a chain is actually the difference is like getting smaller, right? But the key difference, if you think about it, is whether you're composable with everyone that's around you. For a chain, you can choose not to be composable. What does that mean? Is that you control your own sequencing, you control your own fee market, and really you don't actually get affected by congestion around you, right, in the ecosystem. Whereas for a DApp, for a contract, congestion on that chain will affect you, right? If someone do a mint, then all of a sudden fees just skyrocket, and people cannot use your DApp, right? If you launch a chain, that's not a problem. And I think that this line is blurring a little bit. And if you actually apply the thinking from launching a chain to launching a contract, it means that you need to allow developers to specify whether their application can be composed from other applications, right? Whether another contract can call this contract in a blocking way. Because if it cannot, then you actually can have a local fee market. There's caveats, but really that's kind of the fundamental thing. And no one have really came up with an environment, right? Like one single execution environment where that's the case, where a contract can say, I'm going to choose to not be composable to have a local fee market, right? And I think by doing that, for example, you can actually bypass launching a separate chain completely, right? And just say, forget about app chains, just launch an app. It's the same thing because you get a local fee market. There's I think there's things like that they're emerging, and where there's obviously reasons to launch like a roll up, but actually you can turn that, you can add those features back into a singular chain so that people are less likely to like really want to launch a roll up, for example. And that's kind of like future research directions, right? How do you add this to a VM? How can you make this that friendly, right? And I think there's a lot of open questions. If you look beyond kind of, okay, let's just deploy a contract, because I think the end game is just build an app, deploy. You don't have to worry about that. Okay, is this a separate rollup? Is this like on one rollup, right? And you should have a similar set of properties, and that requires a lot of expressivity with exactly what the application developer is thinking about, right? Can I be composed? Do I want to have a local fee market? And but that adds complexity, right? So the trade-off is now, if you're actively thinking about those things, it's not going to be, you cannot just have someone deploy an app like probably in an afternoon. They have to actively thinking about like, do I want to compose? Do I want a local fee market? That's just one aspect, right? But yeah, I think that's something that I'm thinking about, like what is the next generation of systems? What are some of these things that have yet to be sorted out, right?
Dimitri, you have anything to add there? Otherwise, I'll probably ask another question, and we can do a little rapid fire. No?
Use the question to me?
Yeah. Sorry. I was asking if you have anything. Okay. All right. So I kind of one more question on you mentioned expressivity, and that's something that like a word that we throw around a lot. And I want to pressure test one thing just in terms of like our own, like I'll say like positioning and messaging. So switching gears a little bit. When I think about the powerful parts of Fluent and blended execution, like as I'm talking to like more devs and just like seeing what they're attracted to, I think I use the word expressivity, but like kind of functionally what I have in mind is, when people seem attracted to building in Solidity, for example, and then pulling in some Rust libraries, like just as a very simple base case, like we make that really easy because everything's like, sitting there in one state machine, one little sandbox. I think about that as like expressivity because it's like, oh wow, it's so much more expressive. Like you can, you just have all these tools kind of like sitting there in one place, and you can kind of just like remix them, and you can iterate really quickly through. It's not like you have to like rewrite some type of function in like Rust. You could just like pull building blocks off the shelf. To me, that's like, and I'm trying to think of like the right way to term that, right? Like, and so do you view that as expressivity? Like, I don't want to say like composability because then people think it's like composing across. At least when we've used it in practice, people were like, "Oh, so it's like composing across like different chains," and we're like, "No, hold on. It's like within the same environment. It's just like a more expressive one." So I want to actually just pose that question to you. Like, do you look at that as expressivity too, or do you think of would you use a different term?
Yeah, definitely. I think that's traditionally what people refer to like through programming expressivity, right? Like, can I use existing code? Can I, like, how much code do I have to write to achieve a particular task? And I guess I just used it in a slightly different context, which is there's all these extra things that you might want to be able to express as an application developer, right? Do I want to compose? Do I want a local theme market? And that's something that it's not actually possible yet, on current VMs, right? We'll first have to add that feature, and then think about what is the interface to programmers, right? So like, is it a function modifier to say that something is not composable? Is there some other mechanism in the dev toolchain that says a contract is not composable? I think so. I agree. So in most contexts, expressivity means, okay, how easy it is to write something, right? And by being able to import Rust code, using Rust code, we get a lot of expressivity. But what I was referring to is more kind of these advanced features, preferences that devs will later on be able to express. And we're still kind of actively thinking, what is the best way to have the dev express that, right? Because it doesn't exist in traditional programming. It only exists in blockchain programming.
Right. Okay. I know Wei's got to go. We're gonna do like a really quick rapid fire for like, let's just try to keep it under a minute. All yes or no questions. You guys ready?
Yes.
I assume yes. I switched tabs. Okay. So first one, will we see multi-billion-dollar apps built on alt VMs in the next 3 years? Do Wei go and then Dimitri go for each.
Yes, no, right? That was the context. Yeah.
So yes, no.
Yes. Answer is yes. So my answer is also yes.
Okay. Will the EVM remain dominant in 5 years? And will it remain dominant in 10 years if yes?
What is EVM?
That's fair. I think fine, next one.
Yeah, this is hard to say.
Wei?
I would say yes for now. Yeah, I haven't. I'll say yes.
Yeah, I also want to say yes, but I think I say yes because I have different meaning of EVM in this question. So, from my perspective, of course, yes.
These never actually end up yes or no, which is why I'm kind of laughing. But we won't go down the detours this time because we have to go. So okay, so like, should chains be responsible for bringing users to apps?
Yes.
I want to unpack that so bad. All right, we're not going to do it next time. Does chain abstraction apply to devs?
Yes.
I'm starting to hate the word abstraction. I'm starting to hate two words, abstraction and modular, because understanding these two terms is getting much more complicated. I think no, it doesn't apply for devs.
All right, we'll follow up with this offline. I want to know more. Okay, last one. Will alt VMs enable novel apps? Like everyone's talking about it. We certainly think so. Well, I guess I shouldn't answer for you, Dimitri. But will they enable novel apps, or will it be the same old shit for the next few years?
Dimitri, you go first.
Definitely, it will enable new novel apps.
I think I'll answer two answers. Right. One, I think technically I would say no, but practically yes. So like, depending on how you define novel, I think technically novel, it's, things are Turing complete. Like, I think everything's possible. So the technical side of the answer is I don't think so. But in terms of like, okay, is it novel to the users? I think yes, that's that. There will definitely be new applications, new ways to use blockchains.
It's funny because
you can make the same all-cheat applications better.
Yeah, but it's not really novel, right? So, from a technical standpoint, maybe not.
It's actually kind of like a tricky, interesting one because like at the same, you're completely right. Like, but at the same time, like when you have, for example, more expressivity and you can kind of like iterate through things faster, typically people end up like finding product market. They can kind of iterate, find product market fit. They'll make some better things, or if it's more accessible to new people, and then you end up just like increasing the creativity, making better things. So it is kind of I guess not a technical thing necessarily, but anyway. I'm going to let you go. Wei, thank you so much. You've been very generous with your time. This has been super insightful. And appreciate you coming on, man.
Yes, this has been very fun. Thanks for having me.
All right. Thank you, everybody.
Bye-bye.
See ya.